Hello, hello, hello. Good morning. Good morning, Internet. Cabin looks like a nice spot. Yes, thank you, Bert. Yeah, it sure does. That was a few years ago. There's been some landscaping done out there since. Actually, yeah, this was 2 years ago, before the landscaping was done. We did the landscaping last year, and I planted I put down grass seed. So it looks a lot. So it's a bit less rugged out around the cabin there now. Uh, I'm waiting to see now this year once the snow goes, and once I get out there in the summer, I'm pretty happy or excited to see what it's going to look like. Yeah, private and peaceful for sure. Absolutely. It's uh it's on a small little pond. We're the only cabin on that pond currently. There are some other cabin lots on the pond, but they haven't been developed yet. It's quite a marshy area around there, so it's not great for building. Just the cabin that we have was on the lot that used to be a sawmill years and years ago, right? That's partly the pond is like it's terrible for swimming. There's logs on the bottom everywhere. There's leeches. It's not a great pond for swimming, but it's pretty great in the winter when you can get out there on Skidoo and just bar it. Yeah, it's good. It's good stuff. Mm-hmm. Tapes his tongue right flat down on the throttle. Wide open, whatever she could suffer. Taped the wrist all around his hand so she wouldn't slip off. You know how it goes, eh? Hey boy, hey boy, yes boy, yes boy, yes boy. So today, let's see, it is 11:59. All right, so I still have some time to kill with my warm up to the cold open, as Todd Glass would call it. Over here, oh look at this, look at this. You see this? Do 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 do. See that thing? This is I feel like I'm in Snowpiercer. You know, if you've seen that movie, and they talk about like things going extinct. Well, homemade chocolate chip granola squares are about to go extinct. This is the last one. Mom made these. I brought these back in a while back. This is the last one I got. All right, once this is gone, that's it. Well, I mean, I guess I could make some, but you know. Back to my same old tea mug. Just want to prove that it's tea again and not beer, right? Even though it says beer on the front, it's not beer inside. At least not yet. Give me 2 hours or so. Actually, I'll be like Lenny from The Simpsons, right? I'll be watching the shadow of the sun come through. Be like, at this point, draw a line across the floor. At this point, I can drink. So I mean, beer is like you can have afternoon beers. It's fine, right? Because I mean, like beer is under 5%. 5% and under is basically just water, right? Like that's got to be true. So I mean, you can have beer for lunch. You can have beer in the afternoon. You know, you gotta wait. Maybe you gotta wait till like 4 or 4:30 before you can break out the spirits. Anyway, we'll do a math question on like what time of day you can use what percentage of alcohol in your beverage. Mm-hmm. That'd be practical. Okay. All right. So it is 12:02. Boy, I've killed 2 minutes. 2 minutes of class time. All right. Let's flick on back over here. Stream starting soon. Well, guess what? Stream started. Started, boys. Let's do it. Just zoom out my camera a little so we can see the whole page. See the whole page. Math Unit 2, page 71, number 3, 77, number 4, 1 and 2. All right, Esther. Thank you. Okay. I had you down for that first one, but those other ones I will add as well. So let's see. Page 77, 4, 1 and 2. So 1, 2, and 4. Okay. Yeah, let's. So I've got some that are on a similar topic here. I've got three that are on kind of the same topic, and one that's a little different, one that's a little bit. So I'll tell you what. First up, um, I'm going to start off. Esther, I'm gonna leave yours a little bit because I'm gonna do quite a bit on that topic, but I'll get to that then after this first chunk. This first chunk where I deal with a few things that are all on a similar topic. Because strangely enough, a whole bunch of students submitted questions on, actually three students submitted questions on three different courses, but the topic is all very similar. So I'm going to start off with this one here, this 2101B. This is simplifying algebraic expressions involving radicals. Now, excuse me. So let me zoom out a touch so we can see that. Actually, let me switch over to my other display here. We'll see it a lot better. If I switch over to my document display, I might have to reorganize things a touch here. Okay, marvelous. Let's move this guy over. Perfect. There we go. Now it's looking spiffy. Okay. Thanks, OBS. Got my back. Okay, so I'm going to start off with simplifying algebraic expressions involving radicals. So oh, I am needing to zoom out a bit on my cam. There we go. Simplifying algebraic expressions with radicals. Radical. Yeah, it's great. It's like if Michelangelo from Ninja Turtles named a math unit. We'd call them radicals. Okay, cowabungas. Other ones that we will do radicals, cowabungas. I don't know what else. Pizza time, sewer surfing, technodrome. Let's kick shell. Anyway, recite half of Turtles in Time. Anyway, um, so here, state the restrictions on the variable in each expression. Now, it is important to know that this is a course that several of you will have done before, but this is a topic that quite a few people are working on right now as well, right? Math 2101B covers this topic, and Math 3101B covers this topic in a fair bit of detail. And it's very similar, it's very linked. So first up, state the restrictions on the variable in each expression. Root of x. Well, what's the restrictions on root of x? Basically, what this is asking is what numbers can we not get a square root for? And this is actually super important because it kind of leads to like a whole nother branch of mathematics that we don't deal with in these courses, but you would deal with if you went on and did, say, a math degree at a university, or if you did, say, electrical engineering, you'll sometimes see this come up, right? So root of x. Well, basically, what is root of x? Well, to explain what it is, I'm going to draw out a. Tell you what. I'm going to use one of my fancy dice as a stencil. So here we go. Line, 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 line. Maybe that'll be the last time I do that one. Tell you what. No. Tell you what. Maybe I'll just do it freehand. Okay. So we've got a line, a line, a line, and yet another line. Okay. So now, if that is in area x, right? Say the area there is x. Well, what root x is root x is the length of each side, right? So if x equals 16, root x is going to equal 4, right? In this real space thing. But actually, the root of x in algebra is not just 4. The root of x is positive or negative 4. Now, we can't really represent it here because it doesn't kind of make any sense to have a side that's a negative 4 long, right? But it is true that 4 squared equals 16, and also negative 4 squared equals 16. So there are two roots for any positive number. But, well, there's one root for 0. 0 is the only root of 0. Root of 0 is equal to 0. It's totally fine because, 0 times 0 is 0, right? But it's just the 1. It's not positive or negative 0. I guess, But how's about we had root of, say, negative 4? Root of -4, what happens? Well, that's an error, right? Because there's nothing that we can multiply uh, by itself to get a negative number, right? Because any number, if it's two positives, they multiply together, they make a positive. If it's two negatives, they multiply together to also make a positive. So there's no number that you can multiply by itself to give you -1. Now, as a bit of an aside, this results in a type of math called imaginary numbers. Like I said, we don't deal with them on here, but once you get into them, they're actually quite useful. They're kind of like an entirely different coordinate plane. There we go. That's a straightened up a bit. It's an entirely different coordinate plane, sort of, and we can kind of use it to represent sort of three dimensions. We have x and then y and then like I coming out of the page. But really, I mean, that's kind of what z is used for. Here, what we can say is the root of -4 is equal to 2i, because I squared is equal to -1. Now, again, that's a bit of an aside, so I'll put it here in a bubble. That's because we're not going to deal with that in our current courses, right? But for this, we know that the non-permissible values, oh, non values, or NPVs, is that x cannot, oh, sorry, not equal. X, yeah. Okay, I'm sort of sort of blanking here for a second. I'm trying to focus on too many things at once. Sorry, folks. X cannot be less than 0. Or we could say, that the NPVs are 0 and down, right? Or we could say is that x must be greater than or equal to 0. So this is x cannot be less than 0, x is greater than or equal to 0. So for this one here, basically all we're saying is x cannot be negative. So those are our restrictions. So that's kind of what you would put in as the answer. The rest of this is just sort of me explaining how it's going to work and how it's not going to work. Right? For b, b is the square root of x squared. Well, that can be anything. Right? X squared will always be a positive number, so it works totally fine. Let's see, C. So C is the same sort of deal, right? And this is very common in, again, in the 3101 courses, right? So it is another super important thing to get. But basically what we're saying is that x minus 4 has to be greater than or equal to 0, which means x has to be greater than or equal to 4. All right, remember that an inequality like this one, oh, sorry, it's not, it wasn't 4, it was 5, was it? Well, just imagine that I wrote down the right number. What I've written here is still fine. But yeah, if this was what C was, instead of a 5, x would have to be greater than or equal to 4. And we can use an inequality like this. We treat that in algebra exactly the same as an equal sign. We can move pieces around it, left and right, up and down, wherever, right? It's totally fine. So for question, I'll skip D because that's just the same again. For question E, E is interesting because it brings up another one, right? We've got 5 over the square root of x squared. Well, we know from over here that the square root of x squared is just fine. We can just put in any value that we want. But here it brings up another case, right? So the things that make stuff non-permissible. So we'll say over here, I'll write down non-permissible, right? It's 1 is the square root of negatives. We can't have the square root of a negative. And another non-permissible is divide by 0. Can't do that. You also can't divide by 0. it makes sense when you think about it. Like, why can't you divide by 0? Well, what division is it's kind of saying how many sets of one number can I get out of another number? And when we say how many sets of 0 can I get, well, you can always get zeros. You can get as many zeros as you want. You get as many zeros, excuse me, as you want out of any number because it's 0. It's nothing. Okay, so that's why it's just non-permissible. We can't do that because it doesn't equal infinity. It's just an error, right? So here, what we know is that the root of x squared cannot be equal to 0, right? Which means x squared cannot be equal to 0, which means x cannot be equal to 0. So that's our only NPV for e over here, is that it can't be 0. Okay, so that's working through some of those first examples. Let me scroll down a little bit here. Radiation expression in simplest form. Okay, the student asked specifically for the non-permissible values, so I think that should help a fair bit with that one. I hope that answered your question. I believe that was Ali from Kenmount asked that one. Glad to have you with me. I am actually going to go on now to answer some questions from Tia and for the course that Troy is doing. However, Ali, they will be also very relevant to what you're talking about because it carries on. That course carries on with this same unit. So if you're watching the video, you can stick around and you'll probably get some more useful info from the next topic that I'm going to cover as well. Okay, this is why I wanted to do these first because they're all sort of linked. Let's see here now. So we want to talk about the degree of a polynomial. Okay, so let me switch back over to my other display. There we go. Exit out of this guy. Here we are. And pop back over to this one. Okay. So what does the degree of a polynomial have to do with this? Well, this topic that we just dealt with. Well, we'll see now in a second. Is the basic answer because it's all sort of the same unit, right? But Tia asked questions about the degree of a polynomial. Now, there's two ways that we're going to find the degree of a polynomial. One is from the equation, right? Finding the degree of the polynomial from the equation. So I'm going to call this degrees of polynomials. Hey, do you have the Prism Math Algebra Readiness book? Prism Math Algebra Readiness. I'm not sure if I have that one. I have Prism Math Blue and Prism Math Purple. I think purple is the one you're talking about, right? Yeah, I do have Prism Math Purple someplace. RJ. Oh yeah, how you doing? Yeah, good to hear from you, bud. Yeah, if you I can answer questions for Prism Math Purple as well. Yeah, absolutely. So let's see. So degrees of polynomials. So you can find it from the equation or the graph, right? So say we had this polynomial, say it was like 4x squared minus 3x plus 8, right? Here, the degree is 2. So the degree is the highest exponent on the variable, right? So if you're given one just sort of written out like this, super easy. Say you had, I don't know, 1 over 2y cubed plus, I don't know, 11 over 17y squared minus 16, right? say we had that one, we could say here the degree is 3. Right? Yeah, so RJ, if you drop in chat or send me an email, I believe you might have my email. You can just let me know what questions you'd like me to cover, and I will definitely get to them before the end of the stream. So the degree is the highest exponent on the variable. So if you've got it written out like this, super easy. Like you're just done now, sorted, right? Say for graphs it's a little bit different, but it's really not any harder, right? So let me just do up a coordinate plane. Remember, do as I say, not as I do. If you're drawing coordinate planes, please use graph paper whenever possible. This is a stopgap method for me. So this wasn't intentional, but I was going to not have graph paper. So I'll draw one line in blue, like that. I'll draw a curve here in green, like say this. And I'll draw another curve over here in red, say this one. All right? So now, what are the degrees of these polynomials? Well, blue has degree 1. Right? Green has degree, what do you think? What do you think, Twitch chat? Green has degree 2. And then red has degree 4. Think that's true? No. Red has degree 3. You might be seeing a pattern here. Well, from a graph, the degree of a polynomial is 1 more than the number of turning points. So here, this one's a straight line. Let's just say like x equals 1. It's a first degree polynomial. This one is a quadratic. The quadratic turns once. It looks like a horseshoe kind of shape. This is a second degree polynomial. Red over here, this is a cubic. Cubic turns twice. That's a third degree polynomial. And guess what? If you had one that turned 3 times, it'd be a fourth degree polynomial. So on and so on. Right? So naming a polynomial with the degree is super useful, right? Because after linear, quadratic, and cubic, generally you don't hear like special names applied to them. You won't hear them called like quartics or I don't know septics. Septics. That'd be pretty bad, right? If it was a seventh, if it was a seventh degree polynomial, we'll call it a septic. Boy. Short break for some chewing noises on camera. That's good. Look at that. Look at those chocolate chips in that oatmeal. It's the last one I got. Okay. So, maybe I'll do a baking stream after. Try to set my computer up out in my kitchen and show me making some cookies. Hey, I make good ginger snaps and shortbread, let me tell you. Just diving back into math, not even sure where I left off, to be honest. Yeah, no, I hear that. Absolutely. Any questions you got, RJ? Just let me know. If you got my email, you can drop them in there, and I'll get to them on my next stream, or you can let me know during the stream. I do have a copy of Prism Math Purple here, right there behind me. So, yeah, just feel free to let me know. So, Tia, then that hopefully is some good notes. Does this happen every day? Yes, indeed. It happens every weekday. Every weekday at 12 noon to about 2. I'm going to be on here yammering on about math and trying to find as many ways to distract myself as possible, including shiny things, coins, dice, etc. Oh, oh, I wanna you guys need to start asking some probability questions. I've got a kick-ass coin set. Look at this. I went through my coin collection there the other day. I got these guys. Look at these guys. Look how nice these are. This is a set of tell you what, maybe I'll have a competition. Maybe I'll have a stream competition. If you can tell me what country these coins are from, you'll get like, I don't know, a free 5% on your next test. Right? Pretty good. Pretty good, right? First person to tell me what country these guys are from. Let me see if I can zoom in a bit. Look at those. Yeah, you see that? There's 100 fish, 50 fish, 10 fish, and one fish. Hmm. Yeah, that's a good competition. There we go. Try to get people to get some free mercs. Portugal? No, good question. Good guess. Good guess, Bert. Nope, it's not Portugal. Although good, I see why. I see why you've guessed Portugal, right? There's fish on the money, so you'd think, hey, a country that fishes a lot, right? There's a lot of seafaring. So yeah, Portugal's that's a great guess, but no. I have been to Portugal. Portugal is nice. I had the weirdest experience ever in a hotel in Portugal. Like I woke up in the morning and it was like there was steam everywhere and it was super like it was just really hot and muggy and there was like water shooting out and like is that vodka I'm drinking? Yes, yes. This is straight vodka. I'm drinking straight vodka. Um, yeah, so I woke up in this hotel in Portugal, and it was like there was like steam billowing out everywhere. It was like it was really muggy, and there was water seeping out under the bathroom door. And I was like, "Am I? Did I wake up in hell? Is this what this is? Is hell actually just like full of steam and not fire? I don't understand." Turns out something weird had happened with the water, and it was my room that it was happening in, but it wasn't my fault at all. But there was like hot water coming out everywhere, and this is like at like 6:30 in the morning. So I go down to the front desk and I'm like, you know, I was like, what in the world is going on? They're like, yeah, we noticed that there's water dripping down from the ceiling. And I was like, yeah, it's my room, boys. I guess get in there and clean that crap up. So and then I had to leave, right? Like I moved all my stuff away from the water as best I could. Thankfully, my bag was on the other side of the room. And I just like strutted out into Lisbon, Portugal at like 7 in the morning and not having showered and just not being ready to go, but like having nowhere where I had no idea where I was gonna go. It's just like, all right, just gotta strike out and hope that they've got this shit cleaned up by the time I get back. That was a bonkers day. That was the same day I went to Portugal's like knockoff version of that Christ the Redeemer statue in like the real version is in Brazil, right? But then like some bishop from Portugal went to Brazil and saw the statue and like wanted to have one back in Portugal, so they went and built one in Lisbon. Anyway, that was a weird day. Let me tell you. Anyway, yeah. Yes, my ability to distract myself never fails. But for the next questions, then Tia, I hope that answers your degree of polynomials. But I am going to carry on talking about the same course that you were on. So maybe you know you can hang around and look at the next bit. Actually, maybe my hopefully you were enraptured by my story about my crappy hotel in Lisbon. Um, but yes, the moral of the story is that that money was not from Portugal. Maybe I'll put a picture up of it again later, see if people can guess. So I'm going to go over this review sheet here. Right, Tia, this is good for you to still pay attention to because you will have these questions again on your test after. Troy, I believe this is what you're working on right now. So I think I should go down through and talk about this. And Ali, if you are still paying attention, uh, this will this is the same topic that you were asking about, just from a future course. So you will get on to doing these types of questions as well on the same sort of thing. Because here now we have to simplify and state the non-permissible values. Hey, look at that. So this is math 3101B. This is unit 1. Right, and I'm going to start with, what is this, question 2A. We are going to simplify 10x squared minus 4x over 25x squared minus 4. Pop over for 1 second. I just got to check something. Okay. So here, now, there's a whole bunch of steps that we're going to have to take first when dealing with these questions. First up, we have to simplify. Now, to simplify here, basically what we're going to do is we're going to factor out as much of these guys as we can, right? So in this first term, or this first, in the numerator, rather, we've got two different terms, 10x squared and negative 4x. Now we have to figure the largest thing that we can factor out of both these. Well, we can get a 2 out of a 10 and a 2 out of 4, so that works. And we can get an x out of both here. So we'll have our 2x, that's going to be outside of 5x minus 2. Right? Because I've just factored out as much as I can out of both those ones. Now our denominator is a special case. It's a special case called the difference of two squares. The difference of two squares is just a special factoring case that we can do much more quickly if we remember that it exists, basically, right? So instead of having to break it down and use a decomposition method or anything like that, we can just go ahead and take the square root of both these guys. So what this means is if you have x squared minus y squared, that breaks down into x minus y times x plus y. Right? This is a bit of an aside, so again, I'll bubble around that one. Right? So here, 25x is, of course, 25 is 5 squared. X squared is x squared. So we're going to have a 5x and a 5x. And then negative 4 is, of course, 2 squared. There's negative of 2 squared. So it's going to be minus 2 and then plus 2. We see here like this. Right? So now that we've broken this down by factoring, which is a topic that you would have seen at the beginning of the academic math program, can go ahead and cancel these guys. So this 5x minus 2 here is going to cancel with this 5x minus 2 here. And we're going to be left with 2x over 5x plus 2. Okay? So now, how do we determine our NPVs for this question? Well, so that's a second thing that we have to do, right? We have to simplify, and we have to state the, oh, that's not the way I wanted to move that. Hold the phone. Simplify and state the non-permissible values. So our NPVs, remember there's two major situations that we're dealing with for NPVs. You can't take the square root of a negative, and you can't divide by 0. Here we're not taking the square root of anything, so we don't need to be super concerned about the square root piece. But we do need to be concerned about the whole dividing by 0 thing. So we know that 25x squared minus 4 cannot equal 0. So this is our NPVs over here, right? Because the denominator, the bottom, can't be 0, right? Which means that if we move, so now, again, we can treat this just like a normal equal sign. We can move pieces around however we want. 25x squared does not equal 4, which means x squared does not equal 4 over 25, which means x itself does not equal 2 over 5. So there we go. That's the NPV there, right? It's not equal 2 over 5. Let's see, and we square rooted here. It does not equal positive or negative 2 over 5, right? Because this goes back to what I was just talking about. When we take the square root here, it can be a positive or negative 2 over 5, which means it doesn't equal positive or negative. Krona coins during the Corona pandemic. Oof. Big oof. Yes, they are kroner, right? But they're pronounced more kroner. But yeah, so you've narrowed it down. You've narrowed it down to a Scandinavian country, I think. I'll leave them here. There you go. That's right. Albert Einstein got them. These are Icelandic kroner. That's right. Showing a little solidarity with our North Atlantic Islander brethren over there in Iceland. Kroner from Denmark. No, these ones are Icelandic. But I do have Danish krones as well in my coin collection. I've got some coins from every country that I went to. Yeah, showed a little bit of solidarity with our North Atlantic Islander brethren, the intrepid fishermen of Iceland. Yeah, they're getting hit. They're getting hit fairly hard with coronavirus for the size of the nation. A lot of air travel goes through Iceland. So yeah, hopefully they're doing well. I know a guy on the internet who's I believe a banker in Iceland. Oh yes, yes, that's right, Esther. Yes, your husband does is in Greenland a lot, isn't he? Yeah, so he's probably I'm sure he's been to right because Greenland is part of Denmark technically, right? So they use Danish krones. That's right. Uh, Norwegian is krones as well, and I believe Swedish is krones, or the Swedish euro. I can't remember. It's been a while since I've been to Europe. Spelled Europe, Y-U-R-P. Okay. Right. Another thing to mention here is that we always have to use the original. Whenever we're figuring out our NPVs, we use the original one, as you'll notice, and not this one, right? Because if we use this as the NPV, we would only get negative 2 over 5 as the NPV. But that's not the case, because back up here, positive or negative is going to make this not work. All right, whereas down here, only negative doesn't work. So it is important when you find your NPVs, use your original. So I'll say use the original for NPVs, not the simplified. It's important to remember, okay, because if you use the simplified, you're in danger of missing some of the NPVs. Okay, let's see. What else do I want to do here for this one? That was also the difference of two squares. Let's maybe do one that's a little bit more complicated. There we go. Yeah. Yeah, that's a bit more complicated, isn't it? That's just what the doctor ordered, hey. In it. In it, blood. Well, that's bare complicated, isn't it? So you're well harsh, isn't it? Okay. 81 minus x squared. Actually, that has difference of two squares in it as well. We can't get away from it. It's everywhere. 3x squared minus 27x times 2x plus 10 over 2x squared. Rocket science? Yes, that's right. This is literally rocket science. It's not science or involved with rockets. But I could play some Kerbal Space Program afterwards, maybe. I got that on Steam. Haven't set up my stream for it, but yeah, we could do some actual rocket science. Send some minions into space. So that's a fun game. Warzone? Maybe. I don't think my I tried streaming there on Friday, and I gotta say my internet connection is not great. I couldn't even run the long dark very well, and like the graphics are beautiful in that game, but the graphical intensity is not nearly what it would be in a game like Warzone. So I don't know. I don't know if I'd ever be able to stream Warzone. Might be able to play just for just for some fun. But I think next time if I want to stream a game, I might have to do something that's a little bit more low key, a little bit slower pace. Maybe a Slay the Spire or something. That could be fun. Anyway, so here now we can start breaking down each part of this equation, right? So up here, this part here, we know that that one is a difference of two squares is a pong. Yeah, there we go. Yeah, I'll do a pong stream. Now we're getting somewhere. Hell yeah. Maybe I'll do a I don't know, Earthbound. What's a good SNES game? Mario RPG. Um, Mega Man Soccer. There we go. That's a deep cut. Uh, 81 minus x squared. That's going to break down into 9 minus x times 9 plus x, because this one again is the difference of two squares. So down below here, 3x squared minus 27x. Well, we can factor 3 and an x out of both those terms. So this becomes x minus 9 over here. right? And then up top here, I can factor a 2 out of this one, so I can call this a 2 outside of x plus 5. And this one down here is just 2x squared, so it's going to stay as it is. Okay, one other little trick we can do here. This is x minus 9, and this is 9 minus x here. We can't, those two cannot cancel. But there is something we can do to make it cancel. Because if we flip the signs, both the signs in here, then that's going to be the same as down as this one here, right? If we flip the signs. So how do we flip the signs without breaking the math? Well, what we can do is we can put a -1 outside it. Right? Because if we took this -1 and multiplied by both these guys, the signs are both going to change and it's going to go back to this. Right? So I've factored out a negative. Factoring out a negative like that is a super useful thing to know to do. Because it'll save you some work in a lot of situations. This one over here now, I'm going to cancel the 2's, so I'm going to call this x plus 5 over x squared, right? And now we can see that this x plus 9 and this x plus 9 can cancel. So what we're going to be left with then is -1 times 9 plus x times x plus 5 over 3x cubed, right? And I think this is as simple as they're going to want you to go with this question. I can go through and FOIL these guys out, right? So maybe let's do that. So I'll just show you how to do that. So we'll leave the -1 there. FOIL first, these two multiply together, make 9x. These two multiply together to give us a plus 45. These two multiply together to give us a plus x squared. And these two to give us a 5x. And this is all going to be over 3x cubed, same as before. So then these are going to combine together, and we're going to flip all the signs because of this -1 out here. Right? So this is going to be negative x squared minus 14x minus 45 over 3x cubed. And that is, I believe, going to be as easy as that guy is getting, or as simple as it's getting. Now we can also do the NPVs for this one. So this will be the NPVs from over here. We're going to bring it down like so. Now we're going to need to take the denominators, right? So we know that, say, I could multiply them together, but I'm just going to leave them as they are right now. We're going to do two separate instances, basically. We know that 3x squared minus 27x does not equal 0. Right? So that's 3x outside of x minus 9 does not equal 0. Which means neither this one can equal 0, and this one can't equal 0 either. Right? Because here now we've got a factored quadratic. Right? And we know that when we're finding the roots are whatever make this part to be 0 or whatever make this part to be 0. Right? So we know that x does not equal 0, x does not equal 9, positive 9. Right? And it'll be the same thing from this other one. We could also have 2x squared does not equal 0, but that's still just going to get us to be x does not equal 0. So our NPVs for this one are going to be those two. X can't be 0, x can't be 9. Now down here, after we've solved it, x could be 9 at this point, right? But 9 is still an NPV because of this beginning one, right? If we did 9 squared is 81, 81 times 3 is going to be 243, and 27 times 9 is also 243, right? So even though 9 can work down here, 9 couldn't work up here, which means 9 is still one of our non-permissible values. Okay, let me go down through and find one that's a little bit different. I'm not going to do every question on here today, but I'll do 2 more, I think. I'll do 2 more from this unit because this is useful for a lot of the students that have asked me questions recently. So, solve each equation for x, check for extraneous roots. Okay, so extraneous roots are the stuff that we've been checking for so far. I'm going to zoom in on this guy. Put that aside. This is now still Math 3101B Unit 2. Right, and this is, let me see here, 3A. 3A. Okay, so 4 over x minus 2 plus 3 over 2x equals 7 over x minus 2. Now, there's several different ways that you can solve these ones, but I mean, there's several different ways you can solve anything in mathematics. And it's one of my favorite things about math is that once you start learning the concepts behind it and start sort of paying attention to how these things all fit together, you realize that a lot of it is really the same. It's just the same stuff with a little bit of a tweak and maybe a bit of new algebra stuck into it, right? So here, just like any other fraction, what we've got to do is we've got to get the denominators to be the same, right? And let's see, I don't think I did this exact question on stream, but I did last week do the same sort of topic. And like I told you then, if we multiply, we can multiply anything by the same number, right? Because any number over itself is equal to 1, right? And the same is true for a number, but also for an expression. Like say we had, I don't know, 7y cubed plus 4 over 7y cubed plus 4. That also equals 1, right? Because as long as it's the same thing on the top, same thing on the bottom, you're good to go. So we can multiply any of these by sort of whatever we want at the bottom, as long as we multiply the top by the same thing. So my goal here now is to get this fraction, and this fraction to have the same denominator. So fortunately for me, this one and this one are already the same, but I had to deal with this guy over here. So what I'm going to do is I'm going to multiply this fraction by this one, this fraction by the same one, and then this one by that guy. I know it's a lot of words to say right now, but let me write it out and I'll show you what it means. So 4 over x minus 2. This is going to be multiplied by 2x over 2x. Remember, 2x over 2x is the same as 1, so we can always multiply by 1. Nothing happens, because 1 is the identity. That's right. It's another callback. That's a callback to Math 2020. 3 over 2x multiplied by x minus 2 over x minus 2. And we're going to pick a different one here because we want them all to come out to have the same denominator. And this one over here, as long as I don't run out of space, is going to be 7 over x minus 2 multiplied by 2x over 2x. Okay, we managed it, crammed it in there. So let's go ahead and multiply these guys out. So on top here, we're going to have 8x. Down below, we are going to have, I'm just going to leave them in brackets for now. I'm not going to FOIL it. I'll just leave it like that. Plus 3x minus 6 over x minus 2, 2x equals 14x over x minus 2, 2x. Now, again, right, one super nice thing that we've got here now is that since we have the same denominator on each, guess what we can do? We can just strike the lot of them out of there. Get rid of them. Gone. See ya. And what we're going to be left with is 8x plus 3x minus 6 equals 14x. Super easy. This one we haven't even got a quadratic now at this point. We've just got a linear equation. So, really good. We will have negative 6 equals 14x minus 11x. Negative 6 equals 3x. Or then negative 2 equals x. Right? So negative 2 equals x. is the thing that we have found. Oh, yes, I believe I did answer this exact question, didn't I? I think I might have. Because now we have to go back and find, well, what's our NPVs here? Remember, our NPVs, we take the original and we find the NPVs from there. So we're going to have this guy, and we're also going to have this guy over here, right? So we're going to have x minus 2 does not equal 0, which means then x does not equal 2. So over here we'll have 2x does not equal 0, which means x does not equal 0. Okay? So, oh no, I didn't do this exact one. No, never mind. Never mind. That was another one. So x can't be positive 2, x can't be 0. But the solution that we found is x equals negative 2. So negative 2 is totally fine. We could have a negative 2 down here. This one would be a negative 4, this one would be a negative 4, and this one would be a negative 4. Then we'd see if 4 plus 3 equals 7. Well, of course it does. Of course 4 plus 3 equals 7. So yes, negative 2 is indeed equal to x, and that is our answer. And it is a permitted value. So we are good to go. Let's try out, maybe not that one. Okay, sure. Yeah, this one's got a bit of a, this one's got a little bit of a curve ball in it. So let's do this one. So this now is question 3D. Start it over here, and then we'll probably end up using a lot of this other space to finish it. So 3D is 2 over x equals 1 minus 4 over x minus 5. Right? Now I'll wait and do my NPVs after, like normal. So here we have 3 different denominators, right? 1, well, we can call that 1 over 1. Right? Any whole number is the same as itself over 1. So we've got this denominator, which is just x, this denominator, which is just 1, and this denominator, which is x minus 5. So again, we're going to need to multiply by something so that we end up with the same denominators across the board. Here, on the left, I'm going to be multiplying by x minus 5. This 1, I'm going to be multiplying that by x, yeah, let's just call it x squared minus 5x. And then this one, 4 over x minus 5, this is going to be times by x over x. Now, I managed to get that crammed onto the page there. But basically, once we go through and multiply this out, we're going to have this same denominator is going to be for all of them. So we'll have 2x minus 10 over x squared minus 5x equals x squared minus 5x over x squared minus 5x minus 4x over x squared minus 5x. And just like our previous one, what we can do is we can strike out a lot of those. See you later. And we can just deal with the numerators. So 2x minus 10 equals x squared minus 5x minus 4x. Now we can start simplifying this a touch. I'll write out an intermediate step. Equals x squared minus 9x. And then we'll have 0 equals x squared minus 11x plus 10. Okay? So now we got to factor. We have to factor this because we're not nearly done yet. And I'm going to use decomposition method because it is my favorite method. So we'll call this decomposition. So now what I'm going to need is two numbers. So x plus y have got to equal negative 11. X times y have got to equal positive 10. Right? So that's to figure out our decomp method. So how do we do that? Well, two things that multiply to give us positive 10. So 10 is going to be 1 times 10, 2 times 5, and that's it. That's all she wrote. Which of these ones can add to be negative 11? Well, if we had a negative 1 and a negative 10, that's going to do it. It's going to do it, isn't it? So, what I can do now is I can keep writing my equation. X squared, I'm going to break this negative 11 down into a negative 1 and a negative 10. Negative x, negative 10x plus 10. So this is our decomposition method for factoring. I find this one to be the most regimented, right? So now what I'm going to do is I'm going to factor the biggest thing I can out of both these ones. That's going to be an x outside of an x minus 1. I can factor a 10 out of here. I'll factor a negative 10 out of here. Negative 10 outside of x minus 1. There we go. So we have x minus 10 and x minus 1. Right, as our two pairs here, basically. So then we have, as our roots, x equals 10 and x equals 1 are the roots. Right, now we were supposed to check for extraneous roots. So in order to check for extraneous roots, what we're going to have to do is we're going to have to check and see if either of these are one of our non-permissible values for this equation. Right, so if I go down here with my NPVs, right, I have x does not equal 0. Well, that's pretty straightforward. 1 does not equal 0. Well, I don't even need to concern myself with that. Of course, 1 doesn't equal 0. 1 never equals 0. And then x minus 5 doesn't equal 0, which means x does not equal positive 5. And we see that neither of the things that we found down here are either of these. So our roots for this one are good. So both of those are possible roots for question 3D. Okay. All right. Let's see. That was some 3101B review sheet number 1. All right. If anyone has any more questions on that unit, drop them in chat if you got them right now, or if you're watching after the fact, send them to my email, and I will return to that topic then tomorrow if anyone needs any more on it. Like I said, a super useful topic because that's sort of the culmination of that whole non-permissible values or restrictions on polynomials, right? Or restrictions on radicals, sorry. Sort of the culmination of the restrictions on radicals unit. So it's useful for several people. Now, let's see, almost one, good. We're going to pop over to the cabin for a second. Yeah, I wish. There's no internet at the cabin. No internet at all. No contact with the outside world hardly at all. So, can't really, tough to work from home from the cabin. So let me just zoom on in here. So we're going to do some mean, median, mode, and range questions here, which are extremely good topics, like real meat and potatoes. Just nice basic math. I don't mean basic as in like pejoratively. I mean basic as in like the fundamentals, like the base level. It's something that you definitely need to understand. Nothing to do with math. What kind of rig are you running? Oh, my rig. My rig's an i7, early gen i7 though. 16 gigs of RAM and a 8 gigabyte video card. I got a 1070. Right? So yeah, the 1070. The reason I picked a video card with so much VRAM is because I like playing Civ 6 on like stupidly large maps, which needs it. And also, it's pretty good for streaming. Like, I don't have a multiple PC setup like a lot of streamers. Like, if you watch big name streamers who play like super flashy fancy games, they've usually got a 2 PC setup where one PC is playing the game and the other PC is doing the encoding for the stream. I don't have that sort of a setup. I just have the one machine. So that's partly why when I'm streaming, I'll stream games that aren't quite as graphically intense. Like say, I haven't picked it up yet because it's anyway. I haven't picked it up yet, but I'm going to play the crap out of Doom Eternal, but I'm not going to be able to stream that guy. Like, not a chance, because the graphics and the stuff is like just crazy particle effects going everywhere. But I do want to play that game. Oh my lord, it's so metal. Risen 2700 and a GTX 1070 yourself? Yeah, yeah. The 1070 is a fine card, isn't it? Yeah, I'm happy with it so far. Don't have any problems playing modern games or anything like that. Want to switch to Intel? I don't know. Risen's fine. I got an i7 just because that was I just actually bought a pre-built. I bought a pre-built and then I've been upgrading it. Put a new video card, new power supply and stuff into it. Well, yeah, it's um it's good. It's good to keep me going. It keeps me going for now. um, yes, noise, noise. That's right, noise. We're gonna switch over now. We're gonna pivot to math uh, 3102A, and this is Unit 2. I'm going to do page 71. I'm going to do page 77. Then I'm going to do some more questions that I have picked that I think might also be useful. So Esther, first I'll get to the ones that you picked out specifically. Then I'm going to go on and do some others that probably useful for you. Okay, so this is page 71, and it is question 3. The RCMP raise and train dogs for their canine law enforcement work. Oh, that sounds like fun. 9 German Shepherds are being trained. Their weights in kilograms are 38, 42, 44, 43, 40, 41, 39, 42, 38. A. Arrange the data in a stem and leaf plot. All right, great. So, stem and leaves. There's always 2 basic things you need in a stem and leaf plot. You always need the plot itself, and you need a key. Right? It's the main 2 things. Now, when I was in the UK, one thing they recommend is doing 2 stem and leaf plots every time you're going to do one. First, you do one a disordered one, and then second, you put them in order. Right? It's totally reasonable to do that. Makes total sense. But it's a bit more work than what you have to do. So I would say, but the very basics, the least amount of work you have to do is first you need to list out your numbers in order. They have to be in order. So here we've got 38, another 38. Am I on screen there? Yep, 38, another 38, a 39, let's see, a 40, a 41. I'm just putting it over here because that's where I've got space. A 41, 42, 2 42s, 42. If I was doing this on paper, I would be crossing them out as I'm going. But I don't have, I can't cross them out on the PDF document, unfortunately. I don't have a, although, no, I should just get a screenwriter. Hey, oh, that's a to-do. That's a to-do. Give myself a screenwriter. Yeah, allow me to write over just whatever. I haven't got a tablet with a stylus, but I could use a mouse. Anyway, right, digressing. So here now for our stems, we had to take a look and see, well, what first digits do we have? We have 3 and we have 4 as the first digits to our number. So we're just going to have 3 and 4. Those are the only stems that we have. And then our leaves are the numbers that come after, right? So there's 138, 2 38s, and a 39. Then there's a 40, a 41, a 42, another 42, a 43, and a 44. Okay. And the other thing that you need for any stem and leaf plot is you need a key. Got to put that sucker down here. A key, and we generally pick the first example, right? You don't have to. You can pick anything, but I always pick the first, unless there's some strange reason not to. So this is what the key does, is it tells us how to read the stem and leaf plot. So it is important to have one of these here. You'll lose, if the question's worth 3, you're going to lose 1 mark for not having that there. Easy mark to lose, but easy mark to get too. right? So just remember that you need to show an example of how you read, because just from this in the stem and leaf, I'm not sure if this is, 3,800 or if this is like 3,800,000 or what. So down here, 3 bar 8 equals 38. Okay, so that is part A. That's our stem and leaf plot. What is the median weight? Now remember, to find the median, is n plus 1 over 2, where n is the number of numbers. Now remember, this just tells us which of the numbers that we're dealing with is going to be the median. It doesn't find us the median exactly, it tells us which number to look at. So here we've got 9 numbers, so we're going to add 1 and then divide by 2. 10 over 2 equals 5. So we know that the fifth number in order is going to be the median. So then we just go back and count. 1, 2, 3, 4, 5. Median is the fifth number, which equals 41. Okay, so then from B, we find that our median is going to be 41. So it's 1, 2, 3, 4, 5 numbers in a row. Suppose a 10th dog with a weight of 40 kilograms added to the group. What is the new median? Okay, sure. So I'm just going to call this part C. I'm going to go back and add another 40 in here then. I put it in green, so we know that it matches the question that's down here in green. So now there's 10 dogs. So median is 10 plus 1 over 2, which equals 11 over 2, which equals 5.5. Now what? Now what do? The 5.5 number? How do we do? There's no 5.5. But if we have a 0.5 here, that means we need the average. We need to find the number that's in the middle of the fifth and the sixth one, right? So now we go back and count. So it's the middle of fifth and sixth. So 1, 2, 3, 4, 5. So number 5 is equal to 40. Oh, boy, what have I got written here? Number 5 is equal to 40. Number 6 is equal to 41. So what we're going to do is 40 plus 41 over 2, which is going to be 81 over 2, which is going to be 40.5. So now we see that adding this other dog of weight 40 has brought the median down by 0.5. So suppose a 10th dog with weight 40 is added to the group. What's the new median? New median is 40.5 kilograms. Let's see here. What have I got next? Page 77. Questions 1, 2, and 4. So let me scroll down here through my nice, handy electronic version of the guide, of the textbook rather. It's very useful to have. Page 77. Here we go. Question 1. Okay. Mrs. McDonald has 2 grade 12 English literature classes. Morning class is 18 students. The grades out of 100 on an exam were 62, 71, blah, blah, blah. Her afternoon class is 25 students. The grade on the same exams was a whole bunch. Create a stem and leaf plot for each data set. Okay, I'm going to need a new sheet of paper for this one. What are the modes, median, and average for each data set? Is the average mark for the 43 students? Yes. Okay, nice. Good choice, Esther. This is a beast of a question, but it shows us all the different sort of stuff that you're going to have to be doing in this first unit. So, again, this is Math 3102A, Unit 2. This is page 77 and question 1. All right, here we go. So first up, create a stem and leaf plot for each data set. Okay, so let's do set 1 first. Set 1 is, first I'm just going to write them out of order. 62, 71, 58. 50, 46, 95, holy moly, 80, 60, 73. All right, so we'll call this set 1 ordered. Well, what's the lowest one here? It's going to be 50. Then looks like 52. Oh no, 46 was first. 46, 50, 52. Anything else here in the 50s? 55, 55. Then we've got 60, 58. 58 is there. 60 is there. Let's see here now. 60, there's a 62. 68. Maybe this is why we used to make them twice instead of just trying to do this part. There's a 71, a 75, a 73, a 75, and a 77. Let's see, there's two 80s. And 84, a 90, a 92, and a 95. All right. Okay, so that was all put in order there. Yeah, it's a fair bit of number crunching there for that one, right? But now we can go ahead and create the stem and leaf plot for each data set. Right, so our lowest stem is 4. Then we have the stem of 5, the stem of 6, 7, 8, 9. 7, 8, and 9. Right, so before we have 46, if we have 50, 50, 52, 55, 58, 6 we have 60, 62, 68, 71, 3, 5, 7, 80, another 80, 84, a 90, a 92, and a 95. Oh my goodness. Okay, and now like I said before, always remember your key. The key is 4 bar 6 equals 46. And I usually put a little box around that one. Okay, so there's our stem and leaf for data set 1. Right then, for stem and leaf 2, tell you what, how's about I go through and do it out the way I was told before, do an unordered first and then an ordered after. So we'll call this one unordered. Set 2, should I write down ordered set 1 over here. So this is ordered set 1, and this is going to be unordered set 2. So I'm going to do, instead of writing this one out and then crossing it off like that, I'm going to do an unordered stem and leaf, then an ordered stem and leaf. So we see that we have, let's see, our lowest looks to be in the 40s, and the highest looks to be in the 90s. So, right, we're going to have 40, 50, 60, 70, 80, 90. Okay, so I'm just going to go through and just start writing them down in the order that they appear on the page there. So we've got an 84, a 68, a 71, a 55, 46, 63, 46, 63, 72, 92, 70, 65, 54, 48, 73, 88, another 65, Another 73. Oh, that's a 7. 73, a 76, a 53. Oh boy, 62, 90, 40. That person wasn't too happy. 85, 72, 79, 55. All right, no, it actually is a bit easier, right? When we've got a big chunk of numbers like this. This is an unordered set too, and I'm going to do an ordered. I'll do my key with my ordered set. I won't bother writing a key for my unordered, because that's sort of like the unordered set is kind of like you're working as you're going through and figuring it out. Your ordered one is going to be like your final answer. All right, so stem and then leaf. We've still got our 4, 5, 6, 7, 8, and 9. So now I can just put them in order, and since I've got smaller sets, it's a lot less work to put it in order. 4, 6, 0, 6, and 8 there. So this is 3, 4, 5, and 5. This is 2, 3, 5, 5, and 8. This is 0, 1, 2, 2, 0, 1, 2, 2, 3. So that was a 3, wasn't it? That was the second 3. Yeah, because I frigged up. 3, another 3, 6, and 9. 8 is 4, 5, and 8. 9 is 0, and 2. There we go. So our key is 4 bar 0 equals 40. There we have it. Okay, create a stem and leaf plot for each data set. Question 1 done. So, or question 1A rather. That was question 1A. Now for question 1B. What are the modes, median, and range for each data set? Okay, so let's do set 1, the mode. Modes, median, and average for each data set. Average is going to be a bit more work. But hey, you got to do what you got to do. So the mode is just the most common number. So what numbers here are most common? Well, I see 80. I see 80 is there twice. That looks to be the only one. So the mode, or the most common mark, is 80. The median is going to be the middle number, right? So it's going to be let's see, there was 18 students, so 18 plus 1 over 2 equals 19 over 2, which equals 9.5. So the median is going to be the 9th and the 10th, between the 9th and the 10th number. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be 71 plus 73 over 2, which is going to give us 72. So the mode is going to be 80, the median is going to be 72, and then the average is going to be sum of all numbers divided by number of numbers. Right? And I know I'm writing that near the bottom of the page. Hopefully you can see that. Sum of all numbers divided by the number of numbers. Now that's going to be quite a bit of arithmetic for right now. So what I'm going to do is I'm going to bring up the old TI-84, my good pal TI-84, and I'm going to go ahead and start adding these guys. 50 plus 52 plus 55 plus 58, and so on. Where are we here? 68, yep, plus 71 plus 73, 75, 77 plus 80 plus another 80 plus 80, whoop, 84 plus 90 plus 92 plus 95. Going to give us that much. And then there were 18 students. We're going to divide that by 18. We're getting an average of, so it's going to be 1268 over 18. 1268 over 18, which is going to equal 70.44. Right. So now, this question doesn't ask this specifically, but it is the exact kind of thing that does come up when you're using measures of central tendency, is to ask which of these is the best representation of the middle of this data set. Well, is mode the best representation? Well, the mode is 80, right? But the other two are both like 72 and 70. So the other ones are quite a bit different than the mode. Because all the mode is the exact number that happened to come out the most often. But there's 100 different values that a test value could take, even if it's rounded to the nearest percent. There's still 100 different ones, right? So even though it does appear like the biggest cluster is around low 70s, like there's 68, 71, 73, 75. Those are all fairly central and fairly clustered, right? But it just so happens that there were two 80s, right? Imagine if there were instead were two 95s. 95 would be the mode, but it would just be blind chance that two people happened to get exactly 95. So a lot of the time, mode is not a super useful measure of central tendency. Occasionally, mode is very useful, but a lot of the time it's not. And here, then the other two are the median and the average. Now, one of these is more affected by outliers than the other, right? The thing about the average is it just takes the values and crunches them all together. So we call it the average. They're calling it the average here in this textbook, which I don't like. We often refer to it as the mean, right? Because calling it the average seems to imply that it's the best measure of central tendency. And it's perhaps the most common, but it's not always the best. Median is very useful as well because median is less receptive to outliers, right? Like say if there was, just say there was a thing where, I don't know, if you look at the pay that that say people get in a company or something, right? And like one worker is like 35K and another person is like 40K and another person is like 41 and another is like 45K and then like the CEO is like 150K or something like that. I don't know, just some random ass numbers, right? The average of this, if we took the mean and called that the average for this little aside that I'm doing, 35 plus 40 plus 41 plus 45 plus 150, and then divided that by 5, it would look like, the mean here would be 62.2K. But is it fair to say that the average salary of these employees is 62,000? No, it's not, right? Because these four all make considerably less than that, and this person happens to make a whole load more. But if we did the median here is going to be 41,000 because it's just the middle number. Now, does that sound more like a reasonable measure? It kind of does in this case, right? So this is just an aside, but it's an example, right? It's an example of how um, the mean the mean is more susceptible to outliers, the median much less so. Now, in this case, they are fairly close together, and for a normally distributed data set, they are going to be pretty similar. But the more outliers you have, the more the mean is going to be skewed. Oh boy, here we go again. Okay, if you want to get banned from my chat, please show up and drop in crap about buying followers. It's a good way to get yourself bannerino. And by please, I mean please don't. Please never do that. Anyway, obviously nobody that I'm saying that hears me saying that is irrelevant to, right? Because the people that are doing it aren't going to listen, and the people that aren't doing it are just like, you know, just didn't even know what happened. Anyway, where am I here? Right. So that was what are the mode, median, range for each data set? So this is set one. So let's do set two over here. The mode of set two. Well, the mode of set two is again just whichever ones are the most common, right? And the mode can be more than one value. So here we've got, but if everything is only there once, then there's no mode, right? But if most things are there once, but there's like three things that are there twice, then all of those are the mode, right? All those three. So here we have a 55 and a 55. There's two of those. 65 and a 65, two of them. 72 and a 72, 73 and a 73. And there doesn't appear to be anything there three times. So the mode, this one actually has three modes. It has 55, 65, oh, sorry, four modes, 72 and 73. So there's a whole bunch of modes for that one. As an aside, say if there was another 55 here, just to show you, as an aside, so again, I'll put my booble around it so y'all can see. If there was another 55 like that, the mode would be just 55. Because even though there's still two of these guys, still two of these, and still two of these, now there's three of this one. Right? So whichever number there's the most of, or whichever numbers are tied for the most, those are the modes. Okay, so then the median. Well, here in this second set, we have 25 students. So 25 plus 1 over 2 is going to be 26 over 2, which is going to be 13. So it's this 13th number. 13th number equals what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Looks like 70. Let's try that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yep. So 70 is the median. Okay. And now the mean. Now I'm gonna have a little bit of number crunching again here. So let's get my handy dandy calculator. If you don't have one of these at home, you can actually get one of my students before had a really good emulator for this that he installed on his iPad, which had like the exact controls of the calculator, just you didn't have to go out and buy a calculator. And of course, like any phone or iPad or tablet of any kind or whatever will have more than enough processing power to operate one of these guys. It's so weird that like the TI-84 has been the basic design of this calculator has been unchanged in like 20 years, which makes you wonder like why is this still the gold standard, right? Like shouldn't Texas Instruments have been able to do something fancy? But anyway, at least there's some constancy, right? So it's nice in a way. Anyway, yeah, so let's just go ahead and start adding these guys. 40, 46, 48, 53, 54, 55, 55. Not my red one. 62, because that's a bonus one. 63, 65, 65, 68. And Esther, if you're wondering, yes, you have to do this. There's not really any way around adding all these numbers together. It's not really a quicker way of anything like that. This is just it's the way you got to do mean. There we go. 1699. 1699 divide by, wait, how many numbers were there again? 25. 299 divided by 25 is going to give us, 67.96, so about 68. Right? And the average mark for all the 43 students. Well, um, I'm going to cheat a little bit for this last one, part C, because I know that the sum total of all the marks, because I wrote these down, right? The sum total of all the marks in set one was 1268. The sum total of all the marks in this one was 1699, because I left that there. And then the total number of marks is going to be 18 plus 25, like so, right? So we're going to have 1268 plus 1699. We have 2967 over 43. And that equals, heh, nice. That equals 69. There we go. And that is the average mark for the 43 students. Boy, oh boy. That is yeah, that's a long one. One's a bit of a slog, hey. But, you know, none of those steps are particularly difficult. It's all stuff that we've seen before. It's just a matter of putting it all together and knowing when to use those various different ones, right? So that's 3102A, Unit 2, page 77, question 1. Actually, maybe I won't even need to get to those bonus ones I was talking about. I'm definitely going to carry on and get these next two done. Cross that off. Unit 1. Okay, so this is now math 3102A, Unit 2 still. We're going to go to page 78 and question 2. Ooh, that's a whopper. Okay, but these are notes questions. So like I mentioned before, questions out of the notes you have the key for in the back. So I'm not worried at all about showing you the right answer. So I will gladly do any of the questions from the notes that you ask. If it's on an assignment, I might skip some, right? Because obviously you still have to do some yourself so I can know if you're understanding it or not. But for these notes ones, I'll do, yeah, just absolutely whatever. So for the data set of masses, determine each of the following: the modes, the median, and the range. Okay, well, what's the situation? Jimmy is a supervisor at a plumbing supplies warehouse. One of his jobs is to inspect and record the weight of supplies that are, excuse me, hiccups, that are received on shipment days. The table shows the data for the month of June. The month of June. The mode, the median, and range. Okay. So the mode, well, let's see. Are there any numbers that repeat? That's all we're looking for. That's all we're looking for with the mode. Are you seeing my cursor? You're not. Okay, there we go. Cursor on board. All right. 45, 20, 40, 43, 29, 36, 59, 28, and 20. Well, the mode is 20. It's the only number that's there more than once is the mode. All right, easy. Number 2, the median. Well, how many data points do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 different data points. So we know the number that we're looking for is going to be the 9 plus 1 over 2. It's going to be the 10 over 2. It's going to be the fifth one. We're just looking for the fifth number. That's all. Hold on just a second there, Twitch chat. Okay. Yes. Anyone who's contacting me, yeah, I do see all your emails during the stream, and I will start responding sort of immediately afterwards. Got any more active questions tomorrow? Have a good one. Thanks, RJ. Yeah, it's great to hear from you. Have a great rest of your day. And yeah, anytime you want, drop in with some questions. Be more than happy to answer them on stream for you. Okay, we're going with the fifth number. That's going to be our median. So that is, go back on over here. 1, 2, 3, 4, 5. Is that what we do? The 29? No, no, it's not what we do. We don't just count down through those. It's almost what we do, but it's not. First, we have to put them in order. But the numbers in order. Right? Super important. You got to remember to do that one. Put the numbers in order. So we've got a 20, another 20. We've got, let's see, 20 and a 20, a 28, a 29, let's see, a 36. 36. Next one looks to be a 40. Next one looks like 43, 45, and then 59. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, those are all the numbers. Okay, now that we've put the numbers in order, now we can get our median. 1, 2, 3, 4, 5. Median equals 36. The fifth number in order. Okay, and then part tree. The mean. Partie trois. Le mean is going to just be the total of all of those guys added together. So let's bring it up. 20 plus 20 plus 28 plus 29, 6, 40, 43, 45, 59, 320. It's going to be 320 divided by 9, and that is going to give us 35 point, 30, we'll call it 35.6. So yeah, this is a good example of why mode is crap, right? We can see here from this data that 20 is not at all a good example of the middle of these numbers, is it? I mean, like we see over here, look, 20 is literally the lowest number, but it is still the mode because it's the most common number. But it's nowhere near the middle of them, is it? Not even close. Here, the median and the mean are very, very, very close. Even though there's this outlier, this 59 is definitely an outlier, but there's some other ones down here because these 20s are a bit of an outlier too, even though there's two of them. So these are kind of balancing out this 59 and helping the mean and the median be pretty accurate, right? So in this case, these two both come out to be fairly good, whereas the mode is just bonkers. It's way off. James is explaining to a job applicant the number of tons handled on shipment days, which measure, hey, look at that! I did it again. Oops, I did it again. Which measure of central tendency should he use? Explain your answer and state the advantages and disadvantages of each measure. Oh, yeah, baby. That's exactly what I was just rambling about. All right, so for 2B, then mode is crap. Basically, I mean, don't actually write that on your test or something. I mean, you can, but you're going to have to give me some more stuff too, right? So disadvantages. Okay, so mode, disadvantage, it may not represent the middle. The advantage is that it shows the most common result, right? So that's what mode does. Another problem with mode is if you have a more precise measurement, then your mode becomes less and less useful, right? Say you were looking at the mode of heights of students in like a grade 12 class or something, right? Well, is say a student was like 6 foot even and another student was 5'11" and a half, right? Is that the same height? Are you going to round the 5'11" and a half to 6? So is that two people for 6? Or is it one person for 6 and one person for 5'11" and a half? Say another student was 5'6" exactly, another student was like 5'6" 6.2 or something. Six and I don't know, 6 and an eighth. Is that different? You know, 5'6" and an eighth, is that different than 5'6" even? Depending on the on how precise you're being, yeah, that could be different or that could be the same for purposes of mode, right? So mode is, there's a whole bunch of reasons why mode is almost always the worst one. Sometimes there are some cases, and your tests will definitely include some of those. There are some cases where mode is good. Mode is good, say, if you're managing a store and you want to know the most commonly sold item so you can stock more of that, right? It doesn't really matter. Say if it's like shoe size, it doesn't matter what the average shoe size sold is. It matters which ones were sold more than others, right? But now you're getting into types of data that you can't even take a median and a mean for anyway. Like say you wanted to know like the most commonly sold flavor of Mr. Noodles, Spicy beef, by the way, spicy beef, superior flavor. Um, but like you can't even take how do you take the average of flavors? You just can't, right? You can't take the median or the mean of a flavor. Um, so the mode, if the mode is spicy beef because it's the best one, um, it's kind of useful, but you couldn't even have used the other two. So anyway, mode is almost always going to be the wrong one. Median, um, advantage, not skewed much by outliers. A disadvantage, is it well, how do I phrase a disadvantage here for the median? The median is always the middle one, so it might not necessarily represent clustering. Um, but then again, neither does the median or the mean. Means uh, advantage, disadvantage. A disadvantage of the mean is that it is skewed by outliers. I guess we could say the median is like say for example, this is one like the an advantage disadvantage of the median is that the answers may be clumped toward one end, right? So let's say say you had to set like I don't know 1, 3, 5, 5, 6, 7, and then like um, I don't know 14, 15, 17, right? And it skipped a bunch in the middle like this, right? Now, these 14, 15, and 17, you can't really call these outliers here in this case because there's a whole bunch there together. So it looks like there's a clump around like 5 or 6, and there's a clump around like 15, right? But if I was to take the median of this, it would just be 6. The median would just be 6, which does not represent this upper cluster at all, right? Whereas if I was to take the median of these, or the mean rather, the mean would be 1 plus 3 plus 5 plus 5 plus 6 plus 7 plus 14 plus 15 plus 17. And then we divide that by 1, 2, 3, 4, divide that by 9. We would get 8. So 8 would be pulled out over here a bit, which 8 is, it's true that the mean here would be in between both clumps, but it does, in a single data point, it does better represent what the middle of this set would be, right? But most of the time, either your median or your mean will give you a pretty reasonable measure of central tendency, whereas your mode is just junk, right? The mode here would be 5, it would just happen to be 5, right? Say there was, I don't know. Anyway, I'm bleeding about this one a bit more than I would need to. Here, what I would pick either one of these. For this question, I would probably pick the median for this question and say that it is less affected by outliers and therefore it is useful. So part C now, let's carry on. In James's monthly report, he makes the following statement. During the 9 shipment days in June, the average shipment was 35.6 tons per day. Okay? For this report, the accountant was able to calculate the total amount shipped. Which measure of central tendency does James use? The mean. How did the accountant calculate the total amount shipped? Oh, this is like a working backwards question. This is really good, actually. I wanted to get on to one of the more sophisticated working backwards questions before the day was over, because that is a super common one that people have trouble with. But once you see how to do it, it makes a lot of sense, and it's a really good example of knowing. Again, it just goes back to right, knowing the basics of the math allows you to solve like curveball questions, right? So here now for C, well, let's see. James used the mean, right? And the way that he figured it, the accountant figured out the total was that he knew that the average was 35.6 tons per day, right? So this is actually a good link to some math that we were doing a while back. Yeah. So it's 35.6 tons per day, and now we know that it's 9 days. So if we take this and multiply it together, 35.6 t per day times 9 days, our days are going to cancel with days, and we're just going to have 35.6 times 9, which is going to get us back to this 320 tons over here, right? How was the accountant able to calculate the total amount shipped? Well, he just took the 35.6, multiplied it by the 9, and there we go. 320 T. It's a lot of T. A lot of tea to throw in the harbor. It's the wrong country for that, although we are still on the eastern seaboard, so although we're like the far end of the eastern seaboard, right? Like it comes out to a point. Like the United States slopes up, and Canada goes out to a point and goes back. But we're the point. We're the little spot where the Labrador Current meets the Gulf Stream and produces, you know, record amounts of fog. They talk about London fog, right? Let me tell you something. Let me tell you something, buddy. St. John's has a heck of a lot more fog than London, at least in my limited year and a half experience in London. Um, a bit more than a year and a half, closer to two. The manager of a shoe department in a sporting goods store is placing. Actually, was three? What? No, Esther didn't want three. Esther wanted four. Scroll Reno. Discuss the following with a partner. Well, I will yammer about it on stream instead. How's about that textbook? Um, if you know a runner's typical running times, you can predict how well the runner will do in a future race. Which measure of central tendency would you use to predict a runner's future race time? Explain. Hmm. Well, I'm not going to pick the mode because the mode is junk. Well, I'm not going to pick the mode because, like I said before, is 21.1 seconds the same as 21.2 seconds? Because they're both both 21s. Is 21.1 the same as 21.9? I mean, probably not, right? Like that's a big difference in races. So what's the point at which you stop measuring the time and start allowing them to be the same for purposes of mode? It's totally unclear to the point of like mode being super useless whenever it's not that four, not that four. She says, okay, which four are we talking about? Four on the top of page 77. Oh, oh, okay. All right. Well, I guess I don't need to go over that same stuff I was just talking about again. All right. Four on the top of page 77. All right then. So let's do another sheet. Some more paper to take pictures of. Don't feel too bad about me using all this amount of paper because if we were on site, I'd be using like 10 times this amount of paper. So we're still doing our part to save the trees. Save the trees. Although if you've seen The Happening, right? We don't want to save the trees. We want to get rid of them. Spoilers. So spoiler alert. Spoiler alert for Stephen King's The Happening starring was that Matt Damon? Was that Matt Damon? I think it was Matt Damon. Or one of those. It was either Matt Damon or one of those Matt Damon clones. I mean, you know who I'm talking about. Let me see here. Math 3102A Unit 2. Okay, so now we're on page 77. 77. Question 4. Thanks very much for the catch, Esther. Uh, Table shows the number of hours per week that Jacob worked at his part-time job. The mean for the 5 weeks is 21 hours. How many hours did Jacob work during fifth week? Let me zoom in a little. Nope, never mind. Let me zoom out a little. Okay, that's fine. Oh, good, good, good. Boy, I'm from some kind of prescient. What is even happening? This is exactly what I was just talking about, the kind of question that I wanted to show. Okay, so this is one of the working backwards mean questions. Now, how do we find the mean? Well, for any set of numbers, it's the sum of numbers divided by the number of numbers, right? And I will guarantee you that you are going to see questions like this on your assignments and on your tests. So do like put a pin in this one, bookmark this guy, because this one's going to be an important one to know for sure. All right. So here, his first week, he worked 19. The next one he worked 25. Next one he worked 18. The next one he worked 23. And then the fifth one he worked in, because we don't know. We don't know how many that is. But we do know that it was 5 weeks that he worked for. So our total, our number of numbers is 5. Divide by 5 there. And then after we do the dividing by 5, we know that the mean is going to be 21. We were told that. So the 21 goes here like so. All right? So anytime you'd see a question like this where one of them is unknown, this is a step that I'm going to expect to see. I'm going to give you, say if this question is worth 3 marks, you're going to get 1 out of 3 marks just for knowing that you can set that up. All right, so now I'm going to go ahead and add these guys. 19 plus 25 plus 18 plus 23, 85. So this is going to be 85 plus an unknown number n divided by 5 is going to equal 21. Right? So from here on down, this is just an algebra question. Now I know, it's not to belittle it, it's not to make it sound easier than it is. No, algebra is still tricky, and it's still something that people had to remember. But when I mean it's just an algebra question, what I'm saying is that this is there's no new math involved right now. This is just stuff that you've already done and that you're just applying sort of in different ways. Right? See that I've tagged my stream as easy mode. I don't know if you noticed that. I added that tag to my stream there today. And yeah, this is an example, right? It might seem hard at first, but it's easy mode. It's actually totally easy mode. We're going to multiply by 5 across to get rid of that. We're going to have 85 plus n is going to equal 105 because we've multiplied across. Then I'm going to subtract the 85 from both sides. N is going to be 105 minus 85. So n is going to be 20. So now, how many hours did Jacob work during his fifth week? During his fifth week, Jacob worked 20 hours. All right. It's good. It's good. That was, yeah, Esther, that was the other question that you wanted me to cover there. Excuse me. I am going to pop over and look quickly at the review sheet for this unit that you were working on, right? This is the review sheet, so this is one that you aren't graded on, so I'm free to show you all the different ones for these guys. And I just want to show you, again now, another example just like the one that we were just working on. Just to show you that this stuff does keep coming up. Here's another one that is on your review sheet that is just like that guy that we just did. Right? Amy is in a bowling league, scored the following scores in her last 5 games. Right? So in her last 5 games, so I'm going to do this one in black now on the same sheet. So this is going to be a review, U2 review. And this is question number 4. Right? We know that she scored 293 plus 345 plus 300 plus 298 plus 320. And then what score does she need in her sixth game in order to achieve a mean score of 312? Let me zoom out a little bit there so you guys can see it. Score does she need in her sixth game in order to achieve a score of 312? Plus some number, and then it's 6 games, so we're going to be dividing by 6, and that's going to equal 312, just like that, right? So again, right, looks very similar to the previous one there. If this was a 3-mark question, you'd get a mark just for having this guy down like so, right? Now I'm going to go ahead and add those guys together. 293 plus 345 plus 300 plus 29. Oh, that's a 6. 298 plus 320. 1556. So then 1556 plus an unknown number n divided by 6 is going to give us 312. Okay, so now it's an algebra question from here on down. Going to multiply across with these ones. So I'm going to do 6 times 312. It's going to be 1872. So we're going to have 1556 plus n is going to equal, actually I'll write this out, 312 times 6. So 1556 plus n is going to equal 1872. N is equal to 1872 subtract 1556. So n is equal to 316. So, what score does she need in her sixth game in order to achieve a mean score of 312? She's going to need 316. Okay? So that is how we do those. There's plenty of other really good questions on this review sheet, Esther, that I will go over as you get further into the unit. Don't want to overwhelm you too much by doing a whole bunch of different topics right at the gate. But this just goes to show that the question that you just picked out for me to do is an excellent one for you to learn, because it is absolutely going to keep coming back up. So we are nearly done. We're nearly done for the day. I've just got one other one that I want to do, just very briefly here, just to have some stuff there for the student. But Carly, if you are watching right now, welcome. If you're watching it in the future, hello, future Carly. This is past Peter with some work for you. No, this is just me showing. Let's see. I'm going to bring up the. This is the conversion from fractions to decimals section, and I'm going to grab the pre-test to the unit that you just completed, and then I'll work down through that guy. So let's see here. I believe it's the chapter 4 pre-test is what I'm looking for. Actually, no, I guess it would have been chapter 3, wouldn't it? No, the chapter 3 one is not quite so useful. Not quite so useful, is it? Maybe not. Maybe not. Tell you what. I'm going to do this page here on tell you what. I'm going to go ahead and do the one on rates and proportion. I'm going to go over this this sheet in Prism Math Blue. This will be a good intro to the next unit. I'm going to return our view. Peter, for help, go check on your pot of turkey soup. Oh, that sounds great. That sounds good. Oh, you know, I made some soup this past weekend. I had quite the adventure with soup this past weekend. I tried to make a split pea soup just out of dried chickpeas because I don't have any split peas left. And I got a load of dried chickpeas from like years ago that I bought at like Atlantic Cash and Carry, I think, up behind the mall. Yeah, so I just followed the package. I rinsed them a bunch, soaked them overnight. I cooked them and I drained them, cooked them in my slow cooker for, oh, I don't know, like overnight again. Like they were cooked in the slow cooker for nigh on 24 hours, and they still hadn't turned into anything close to soup. They were still very firm. But I mean, it's chickpeas, right? They weren't made to be soup, I suppose, or were not intended to be soup. So I went ahead and got my immersion blender out and just like blended those suckers. Just went ham on them. Just it's pretty great. Then I got like a pureed chickpea. I went and fried up some cubed up pork chops and some onions and carrots. Yeah, some chicken stock. Threw it in there. Made kind of like a split pea soup out of it. It's tasty. It's tasty, but the texture is a lot more like a curry than it is like a pea soup. But hey, you know, I think it's doing okay. So this is just going to be ratio, rate, and proportion. So this is just sort of a beginning thing. So Carly, this is the beginning of the next course that you're doing. You didn't seem to have any problems on your last one. The work was very good, and I will send that to you, the corrections to you this afternoon. But first, I would like to go over a bit about what you're going to be seeing in the next course that you do, right? And that one's going to be ratio, rate, and proportion. So I'm going to do the pre-test, which is going to be page 88 here, like this one. I believe this is the next course that you're on to, and if not, well, I'm just ignore everything that I'm saying. Okay, so 8 runs in 6 innings. Like, how do we represent that as a ratio? Well, a ratio is always represented. We read it as 2. We call it 8 to 6. That's an 8 to 6 ratio. But if we were to write it out, we write it with a colon like that, 8 to 6. Then we can also reduce these down to simplest form, the same way we can reduce down a fraction. So this is an even number and this is an even number, which means we can divide both of them by 2. So we end up with a 4 to 3 ratio. And that is the simplest form. Okay? And I know sometimes your book shows you doing them as a fraction. I would strongly recommend keeping uh, the ratios as a colon, like so. All right, say question 2. 2 pies for 10 people. 2 pies for 10 people, unsurprisingly, that's a 2 to 10 ratio, or a 2 colon 10, or in simplest form, 1 to 5. Right? Like I said, I'm just going to go down over the pre-test. 6 books to 2 tables. 6 books to 2 tables is going to be a 6 to 2 ratio, or a 6 to 2, or a 3 to 1. And then the next one is 3 assignments in 5 days. 3 assignments in 5 days is going to be a 3 to 5, or just a 3 to 5. There's no way to reduce that guy down. It's as simple as it's going to get already. Right? The rest of these now are a little bit more involved questions, but not much. So circle each pair of ratios that are equal. So we have 5 over 8, 15 over 24. Well, these are just fractions actually now. We have 7 over 12, 11 over 18, 3 over 4, 16 over 20. We have 2 over 3, 32 over 48. We have 4 over 5, 4 over 30, and 5 over 6, 20 over 24. So now we have to check and see which of these are proportions, which means which of these, it's happening again, isn't it, Twitch chat? I just dropped a bunch of frames every day at around 2. It's always around the end of my stream. Stuff starts getting messed up, and I start stopping. I don't know. I even called Rogers the weekend and tried to give him a sob story. Like I was like, "Oh, I'm just a teacher who's working from home, so pretty please, I need to get some internet." can you please give please, sir? Oh, please, sir, can I have some more internet? I just want a bit of internet, please, sir. And he says, what? You want more? And then smash. They just, you know. Anyway, it's like Oliver Twist, but for 2020. That's my story. Let me tell you. Oliver Twist for 2020 will be like 140 characters long, right? None of this like I don't know 700 pages of nonsense like whatever Dickens is writing, right? Like people's attention, like it needs to be a Twitter length. Um, Great Expectations is what I'm saying. Oliver Twist. What? Anyway, something by Dickens. I just had a I just had a message. Phone's popping off. Okay, so over here now, we're going to check and see if I can multiply the top and the bottom here by the same number to get to this one, basically. So we're trying to see if these fractures are the same. Well, um, another way to do it is to see if I take this one and divide by that, is that the same as this one divide by that? That's what I'm going to do. So 15 over 5 is equal to 3. 24 over 8 also equals 3. So this one checks out. It is a proportion. All right, so that one is equal. So I'm going to put equal signs in between here to see if, yeah, instead of commas, I'll put equal signs. Then I'll say if it's right or wrong. So here we've got 18 over 12. We know that 18 over 12 is going to equal, let's see, 3 over 2, or 1.5. 11 over 7 is going to equal not that. I'll tell you right now, it's not that. 11 over 7 is going to be 1.57. So this one is wrong. Wrongo. That one is not. So this one is a does not equal. Okay. So same with this guy over here. Let's check this out. So it's 16 over 20. So let's see. 20 over 4 is equal to 5. 16 over 3 is equal to, it's going to be 5.33. So this one is wrongo. Does not work. Right? So we're starting to see here now. This one, 32 over 2 is going to be 16. 48 over 3 is 16. So this one checks out. Checks good. This one, 24 over 4 is equal to 6. 30 over 5 is equal to 6. Checks out. Math checks out. And you're seeing what I'm doing here, I imagine, by this point. Checks out. Good stuff. Okay, let me move the book. It's not a great spot for it. So now then, for questions, that was questions 5, question 6, and question 7. So then for question 8, we have 7 over 9 is equal to 21 over n. Now this is a really good question because these are the important ones that are really sort of the basics of this whole course that you're going to be doing next. Super important type of math here because this is cross multiplying. It's a very important math concept to know. It's real basic algebra that is incredibly useful as you're going to go through a lot of different courses. Treat you to a... Nope. Don't let me zoom back out maybe. My picture of the cabin. I want to get a better angle on that guy. Maybe I'll move it over a touch. There we go. Cool. Maybe a little bit to this side. There we go. Nice. Nice. Anyway, so we're going to cross multiply here. What cross multiplying means is if we have x, y equals a over b, Once we cross multiply, we're going to have xb equals ay. Right? So this sort of comes up like that, and this one comes up like that, and they cross over, like so. Right? So we're going to do the same thing here. We're going to have 7n equals 21 times 9. Right? 21 times 9 is going to be 189. So what we have is 7n equals 189. Now we have to get rid of this 7 that's here by the n, because we have to have n by itself in order to answer. So we're going to have n equals 189 over 7, or n equals 27. So there we go. Right? That is the cross-multiplying method to find these. Now, I know this might look daunting. There is a whole bunch of different ways to do these questions, but I strongly recommend that you get used to this guy, this cross-multiplying one here, because it's very, very useful, and you'll see it a whole bunch of times. There are some other ways that we can do these ones. Let's see. Actually, I'm going to stick with showing you these, I think. Upon consideration, I think I'm going to stick with showing you the cross multiply method, because getting used to this will be very, very useful as you go on in the rest of your courses. So b is going to be 2 over 3 equals n over 24. Going to cross multiply. We're going to get 2 times 24 equals 3n, right? Or it's going to be 48 equals 3n. 48 over 3 is equal to n. So then it's going to be 16, I believe. 48 over 3, 16. 16 is equal to n. You needn't write out all these steps, but I am just going to do it anyway. So 9a n over 13 is equal to 35 over 65. How about this time? Let's make it a little easier on ourselves. Let's make it a little easier. And before we do our multiplying, I am going to cancel as much as I possibly can. So 35 and 65, I can divide both those by 5, right? Divide this by 5, divide this by 5, just to make it easier on ourselves. N over 13 is going to equal 7 over 13. Oh, hold on a minute. Now that they've got the same denominators, if two things have the same denominator, we know the tops are equal, right? So I've kind of just sort of shortcutted my way to the end of this question. Right, so maybe it's not the best example for the instructor to be doing. But I'll go ahead and show you the cross multiplying anyway. 13n is going to equal 13 times 7. So 13n equals 91. N equals 91 over 13, or n equals 7. But from up here, we could have skipped straight down to that, right? Because we know that if the denominators on both sides are the same, we can just get rid of them and just have n equal 7 right from the get-go. Right? 9b then, 8 over n is equal to 4 over 3. Going to do my cross multiplying and get 8 times 3 equals 4n, or n times 4. 24 equals 4n, and then 6 equals n. All right, just going to pick it up and get through these ones. Let's see, 10a. 10a is going to be 3 over 5 equals n over 100. 300 equals 5n, and then that'll be 60 equals n. Okay, because I'm just skipping a little bit of writing it all out. N over 7 is equal to 20 over 28. So again, here we could reduce these down first. We could divide both these by, say, 4. We can have n over 7 equals 5 over 7. So I can just call that n equals 5. Right? Because they have the same denominator on both sides. Okay, so Carly, then, yes, that is the pre-test to your next math course, I believe. So this isn't any of the questions that you are responsible for, but this is a good summary of all the different topics that you'll be doing in that course. So yeah, if you watch the video there, and I'll link you to the video itself, the point in this, excuse me, in this broadcast, so you can watch it over again if you have any questions. And feel free, please, to let me know of any ones that you're currently working on, and I can go through those on stream as well and send you those. Okay. Yeah, thanks for sticking around. Thanks for being here with me today on this fun day math day. Yeah, welcome to I mean, this is the second week of our distance program. I'm glad that it's going so well. I'm super pleased to see so many people participating and still doing work. The amount of work that I'm getting in is excellent. I'm really glad to see so many people participating and continuing to get their education and to get their work done. Yeah, you're making great use of your time, and hopefully it's giving you something productive to spend some of your time doing. I'm really happy to be able to be helping you guys this way, and yeah, super pleased that you're coming on, paying attention, participating, and yeah, glad that glad that everything seems to be working out. Um, yeah, and if you even if you want to come on and just chat about anything, about how you're feeling or anything like that, we have time after the stream, or you guys know my email address and Skype contact and all that. We've been over those ones. Um, yeah, maybe for later on in the week, I'll look to doing something recreationally uh, after some of the stream ends, or maybe in the evening sometimes. But anyway, I hope you're having a great Monday afternoon. Um, yeah, let me know if you got any questions, and I hope to see you again tomorrow. All right, see you later, Internet.